everyone. So welcome back to Cloud BI Academy. Today we are diving deep into advanced SQL topic covering Windows functions, common table expression and indexing. These are the crucial concepts you must master for the advanced SQL development and crack job interview confidently. So grab your note and let's begin. So first let's understand Windows function. So Windows function, also known as analytic functions, allow you to perform calculation across a set of rows related to the current row without grouping the data into a single output row like aggregate function do. In simpler term, imagine you are looking at each row, but you can also peek into other row around it. So based on partitions or ordering and calculating things like rank, sum, or moving averages. So this is the syntax for the our Windows function. So here we are calculating the rank of employee within their department based and on the salary. So partition by groups the rows by department and order by decide how we rank them within the each partition. The magic is we don't collapse the row like group by would. Every employee still shows up just with their rank added. For example, I have shown the result set for that. So as you can see, employee are ranked with their department based on their salary. So this is the HR department data and this is HR department salary and this is the rank for Alice and Bob. Same as it is for the IT, but the original table remains intact. Okay. So some commonly used Windows functions are rank, assign rank, but skip number if there is a tie. Dance rank like a rank but doesn't skip number. Row number simply numbers each row sequentially. Lang and lead allow you to access previous or next row values. So we are different. Interviewer often ask, what is the difference between rank and dense rank, and when would you prefer row number over rank? So here are some comparison between them. Row number always unique. Rank may repeat. Dense rank also may repeat. Skip number, there is no any skipping the numbers, but in rank it is yes, and in dense rank no. Handling ties like different numbers, same rank. So we can go with the more examples like in this data there is a employee list are there, and based on salary we have order by based on the salary. Okay, so this is the row number. Here you can see there is no skipping of rows. Based on the salary, it is getting row number. Okay. In rank, here you have seen for 7,000 two time repeats. So that's why this rank is showing two time 1 1 and 6,000 coming on a third level row. So that's why it is showing as a 3 here. Again, this is a fifth row for us. So that's why it is starting from the fifth. And same it is for the dense rank also. So here you have seen 1 1 is repeating two times, but it is not skipping the rank. For next one, it is assigned 2 and 2. Same it is for the next one, it is assigned 3 3. So this is a common difference between row number, rank, and dense rank. Okay, so moving on, let's talk about the CTE or common table expression. So a CT is a temporary result set that you can use reference within another SQL query. It makes your SQL cleaner, modular, and more readable, especially when dealing with the complex joins or recursive operations. So this is the syntax for the common table expression. So the it is started with uh, sorry. So common table expression, it is started with department salary. Okay. So this is a one block of code where we have getting average number of salary. Okay. So here we create a temporary table called department average salary. Okay. And calculating the average salary per department. And here we have grouped because here we have grouped the based on the department ID. So it is calculating the average salary per department. Then we join the CT back to the employer table to compare individual salaries and department average. All this happen within a single query. No need for messy subqueries here. So here we have joined employers and department salary based on the department ID, and we retrieve our data. So this is a simple thing here. This is a one block of code where we have stored all the things in our temporary things, and this then we so it is a creator just a like a result set. Okay, and we have used this result set with our current table and get the fetch the what as per our requirements. And for the same as it is, we have using the recursive CT. So this is an example of a recursive CT which is externally useful for hierarchical data such as organization chart where employee report to manager. Okay, so in this employee hierarchy, employee ID, manager ID, okay, union with this one. So we build the entire tree of employee reporting their manager step by step. Okay, so based on that hierarchy we get our data. Finally, let's explore indexing. And index is in SQL works just like a table of content in a book. It helps the database engine locate information faster without having a scan every row. There are several type of indexes. Cluster indexes. Uh, so cluster indexes records the physical data. A table can have only one. Okay. For non-cluster index, for non-cluster index, a separate structure pointing to the data. And next one is unique index, prevent duplicate entries. And composite index, it is including two or more columns. So choosing the right type of index depends heavily on your query pattern. When to use index? So use index when you are filtering data using where. Okay. You have frequent joins, sorting using order by on a large data set, and where we have avoid so a small table overhead isn't worth it, and column that change often because updating an index also cost performance. So here we have avoid the things. I have also created a video for cluster and non-cluster indexes, so you can refer that video. So a common interview question: what happen if you index a column with many duplicates? So for that answer is it has a low selectivity, may not and may not improve performance much. So all right, let's quickly summarize what we have learned today. Windows function analyze across rows without collapsing data. Common table expression make complex queries easier to read and maintain. Indexing speed up data retrieval but use it wisely. Now I want to hear from you. Which SQL feature do you find the most powerful? Windows function, common table expressions, or indexing? And why? Drop your answer in a comment below. If you enjoy this video, don't forget to like, subscribe, and hit the bell icon for more powerful SQL content. In the next video, we will uncover SQL optimization technique and execution plans. So stay tuned and also check out descriptions to download today free SQL cheat sheet. Thank you for watching.